All right, so today what we're going to be talking about is how we solve quadratic equations. So we just spent the last 2.5 days factoring, right? So do you think possibly factoring is going to be part of how we solve quadratic equations? Do you think it's going to be the only way we solve quadratic equations? No, absolutely not. So we're going to look at different methods in solving quadratic equations, one of them obviously being factoring. All right, so next page. Obviously, when we're dealing with quadratics, we like them to be in standard form. Standard form being that ax squared plus bx plus c, right? That's nothing new there. You guys have been using that for a while now. What we're tacking on to that factoring piece is that zero product property. Do you guys know what that means? Set what equal to 0? The factors you're going to be setting equal to 0. Okay, so that's something that you've already know how to do this. You've done it many times before. So now we're just going to be kind of putting in a little bit of an extra spin on it. Okay, so how do you think I'm going to start this one, guys? Yeah, let's factor it. Okay, how does this factor? Good. X minus 7, x plus 3, and what do I need? Equal 0. If you don't have equal 0, is it wrong? Yeah, okay. Right, when we started it, it was an equation. If you lose that equals 0, you're turning it into an expression. You can't solve an expression. You can only solve an equation, okay? So you have to make sure you have that equals 0 every time. All right, now what? Set the two, what do they call it? Starts with an F. Factors. We're going to set those two factors equal to 0. Good. And what is that called? Zero product property or zero product rule. Okay. So each factor gets set equal to 0. All right. Good. And then we solve for x. X equals 7. X equals negative 3. When I have more than one solution, how do I write my solution set? Negative 3, 7. Curly brackets, I guess they're called braces, right? Okay. Difficult? No, so it's the same thing we've been doing, except now we've added an additional step on for where we're actually solving for the variable. Are we okay so far? All right, so let's move on to the next page. Okay, now how is this one different? It's equal to a negative 15, so is it set equal to 0? Do I want it to be? Yeah, absolutely. So what am I going to have to do to start? Good, let's add that 15 over. Okay. So I want my quadratic set equal to 0, especially if it's a trinomial. All right, what else do we see that's problematic? It's got that 2 as leading coefficient. So what am I going to have to use? AC method. Good. How do I do AC method? A times C, so 2 times, which is 30. Good. I need two numbers that are going to multiply to be a positive 30 and add to be a negative 11. Negative 6, negative 5. Great. Are we okay with that? Okay, now what? Good. So what I've done is I've broken up that negative 11 into negative 6x minus 5x. Okay. All right. Split it. So first half, second half. Good. GCF for the first half, guys. 2x. Good. What goes in my parentheses? Great. GCF second half. Negative 5. Good. And my parentheses? Now, what always has to happen, guys? Yes, we're going to take those numbers that are sitting out front. But what about what's in the parentheses? They always have to be the same, right? If this is x minus 3, this has to be x minus 3. If they're different, you've done something wrong. Okay? So we take what sits out front, 2x minus 5. We take their common factor, x minus 3. And we set it equal to 0. All right, now what? What's it called? Zero product rule. Okay. How do I solve it? Add 5 and add, okay, add 5, add 3, divide by 2. So I get x equals 5 halves and x equals 3. All right, let's look at the next page. All right, go ahead. I want you to give it a shot. See if you can try it on your own. We'll go over it in a second. And anyways. Okay, first step. Subtract 18. Don't say minus, it's not a verb. Okay, now what? X plus 9, x minus 2 equals 0. Okay. Okay. X plus 9 equals 0, x minus 2 equals 0. Is this easy stuff? That makes me happy. That's because we all know how to factor because we spent 2.5 days practicing, right? Okay, good. Any problems with this? Are they all going to be this easy? I mean, they don't get that much worse. Okay, so here's our next one. Now, is this a normal looking trinomial? Is it a trinomial? Okay, it kind of is. Notice I have an x squared and I have an x, right? So my last term, my c term, would be 0. Okay, now, how do you think I'm going to start this? Yeah, let's subtract that 8x over. Now, are we always going to be able to factor like with our 2 sets of parentheses? And no, this is different, right? Are we still factoring? Sure, but this time I'm looking for a what? GCF. Great. What's my GCF? Good. Okay, so 8x is my GCF, so that's going to go out front. What goes in? Great, 2x minus 1. Is everybody clear on how we got 2x minus 1? If you're not, speak now or forever hold your peace. We're good. Okay. Now what? Set what equal to 0? Good. Both of the, what are they called? Factors. So 8x equals 0. 2x minus 1 equals 0. Each factor gets set equal to 0. Okay. Now what? Divide by 8. Good. 0 divided by anything is 0. Can you have 0 as an answer? Can you have 0 as an answer? Yes, 0 is not some scary number that cannot exist. Okay, you can have 0 as an answer, absolutely 100%. Don't reject it just because it's 0. Okay, I've seen many of you do that. Now what? Other side, add 1. Divide by 2. 1/2. Good? Problems, questions, concerns? Great. Ready to try another one? All right. Let's try another one. Okay. Why don't you go ahead and give it a shot, and we'll talk in a minute. Let's go. How do I start? GCF. What's my GCF? So this gives me x squared minus x squared minus 36. Great. Difference of 2 perfect squares, right? Right, Peter? Yeah. All right, now what? Yeah. 0 product rule, 5 equals 0. Is 5 a factor? Yeah, absolutely. Okay, so I'm taking each factor and setting it equal to 0. Now, can 5 ever equal 0? So that gets rejected. Okay. X plus 6, what do we get? Negative 6 and 6. So I get plus and minus 6, right? Negative 6, positive 6. How are we doing? We're not done. We're not taking naps. Are you ready? Moving on. Okay, go ahead and try this one. Okay, so some of you went ahead and did this, right? You said, okay, let me get it equal to 0. And then you said, oh, 3 is a GCF. Let's take that out, right? And then you got stuck here. Yeah? Okay, let's do that. If you want to start it this way, we can. There's the easier way. We'll do it both ways. That's as factored as it gets. So now let's take it from here. Good. I'm going to add that 8 over, and I'm going to take the square root. Okay? Remember, when you take the square root for these, it's always plus and minus. It's just a number. Plus and minus always for the square root. How can I break down the square root of 8? 4 and 2, which gives us what? 2 radical 2. So I get plus and minus 2 radical 2. So that's one way to do it. Okay? The other way would have been to start by dividing by 3. Would have automatically given us x squared equals 8. Okay? Again, I said it doesn't always have to be factoring. Sometimes we can use square root, right? Square root of both sides. X equals plus or minus 2 radical 2. Okay? So there's more than one method. Okay, word problem. Firefighting, smoke jumpers. Are you guys ready? I'll wait. I'm a very patient woman. Very patient. Very, very patient. Not so much. I'm just kidding, but I'm going to be patient. Are you ready? I'll wait. And the video is recording, so I have proof that this is going on. Okay, firefighting. Smoke jumpers are in free fall from the time that they jump out of a plane until they open their parachutes. The function y equals negative 16 t squared plus 1600. Models the jumper's height y. What's height? Y. In feet at t seconds. What's t? Time in seconds, right? Okay. For a jump from 1,600 feet. So we're 1,600 feet high. We jump out. We're in free fall until what happens? Until the parachute opens. Okay. How long is a jumper in free fall if the parachute opens at 1,000 feet? So again, let's talk about our variables. What's y? Height. What's t? Time in seconds. Okay. Question's asking how long, which means I'm going to be solving for what? T. Are they in free fall if the chute opens at 1,000 feet? What should I do? Where am I going to substitute 1,000? For y. Very good. Okay, so we're going to have as our equation 1,000 equals negative 16t squared plus 1,600. Now what? Subtract 1,600. Very good. Okay. Divide by negative 16. Okay, so that's a good question. Do I want it in fraction form? Let's think about time. Time is generally not in fraction form, right? So you should probably give that to me as a decimal. No? What? What? I can't, I can't hear. Thank you. It's my old age. My hearing's starting to go. Okay, good. Now what? Square root, good. Square root, always plus and minus? Okay, so last time when we looked at, let's say we had x squared equals 9, right? You took the square root and you got x equals plus or minus 3, right? Okay, let's talk about the context of the problem. What are we solving for? Time. You have negative time. So we're going to use that negative root. No. So what we're solving for here is what's called the principal root. The principal root is the positive root. Okay. Can I round that? Yeah. But when you round, you had better show me this last one, the long one, before you show me the rounded one. And I want the units, which is? Okay, so t equals 6.1 seconds. Okay, so how do we solve these by graphing? So not every equation can be solved by factoring. Sometimes they're just too ugly, they're not factorable. There are other methods, but we're only going to focus on graphing for today, okay? So another method of solving these is to graph the quadratic. The solutions can be found where the function crosses the x-axis, okay? So you've heard both of these words before, zeros and roots, right? These are two different things. The zeros are the solutions, x equals, okay? Roots are the points. 3, 0 would be a point, right? Okay, they're two separate things. So if I want the root, I want a point. If I want the 0, I want x equals. Okay, root point, 0 solution. Say it, root point, 0. You need to know that, okay? So let's look at how we find them here. I've got x squared minus 5x plus 2 equals 0. So what do I want? The root or the 0? I want the 0, okay? Because it's set equal to what? 0. I want the solution. Okay, x squared minus 5x plus 2. Go ahead and insert a graphing page. X squared minus 5x plus 2. Thank you. And graph. X squared minus 5x plus 2. Okay, so again, my solutions or my zeros can be found where? Where it intersects that x-axis, right? So here's what you're going to use. Are you ready? Menu. I guess we could use analyze graph. Either way, works. Well, what am I going to use? Yeah, 0 works for me. Okay, so now, this is generally why I don't use analyze graph, but we can do it this way. It's asking for my lower bound. I'm going to go to the left of one of my roots, and then it's asking for my upper bound to the right. Now, here's the problem with this. How many did it give me? How many do I have? So I'm going to have to use the tool how many times? Twice. Okay, so yes, I can absolutely do it this way. Menu, analyze 0, and do it again. And now they're both there. You have to do it a second time. Lower bound on the left-hand side, upper bound on the right-hand side. Okay, so my solutions are now x equals 0.438, 0.438, and x equals 4.56. Okay? You're going to have to, did you go menu, analyze? You're going to have to do it again. I'll look in a minute. Okay, so the other method here. The other method. Are you ready? Ready? Other method, menu, geometry, points and lines, point on. This is the one we use for everything else, right? Why not continue to use it? Click on the quadratic and hit enter. Grab that point and drag it. Ooh, that's not what I meant to do. Control Z. Grab the point, drag it, and what's it say? 0. So it'll tell you what the 0 is. Grab it and drag it again. Lost it. There we go. There it is again. Okay, so either way will give you the answer. Okay, I don't care what method you use as long as you get it right. Okay, so go ahead and try the next one, please. What are you going to have to do before you can graph it, obviously? Set it equal to 0. Okay. Okay, here's my graph, right? Menu, geometry, points and lines, point on, click, enter, grab. Why do I keep doing that? Let's try this again. Grab that point. Here's my 0. Negative 1.19. It's not the right equation, is it? Give me a second. How's that? That's better. Okay. Negative 1.24. Get the first one. Second one. 3.24. Any problems, questions, concerns with graphing? Do I need to do any more of these? Okay, we got one more thing we got to talk about, and then we're done. Let's scooch ahead to some and product of the roots. Okay, this is important. These two formulas need to be memorized. They are not given to you on your reference sheet for the Regents exam, okay? But they're incredibly easy to use. Sum of the roots, meaning your x values, right? When you add them together, what the sum is, and when you multiply them together, what the product is. So your formula for sum is negative b over a. Your formula for product is c over a. Where do I get a, b, and c? From the quadratic. What form? When it's in standard form, which means that ax squared plus bx plus c. Okay. Let's look at this first one. Now, when you do these, if you just put negative b over a and c over a without labeling which one is sum and which one is product, it's wrong. Because I can't assume you know the difference between the two. Okay? So let's find the sum first. So negative b over a. What's b in this case? Negative 3. So I wind up with a negative 3 over a, which is 2. So I get 3 halves. Difficult? Product. C over a. What's c? What's a? 1 half. Think we can manage that? Okay. Yep. All right, so next one. Sum. Negative b over a. What's b? 6. What's a? Careful. Negative 1. So what's the sum? Positive 6. Product. C over a. What's c? Negative 4. A. Product. Good? Okay, your homework is pages 15 and 16 tonight. Okay, you should have no problem with any of that. I want it all done. Weekly project for you guys will be due Thursday, 10 problems. It's all review, nothing new. What? Okay, do not take your cradles off.